So, lesson number 3 then. This should recap what we were looking at last time. The question is a little ambiguous as to whether we're looking at positive, negative or no correlation for technical ability and artistic merit in this case. But I guess it kind of makes sense that we'd be looking for a positive correlation between the two. You wouldn't assume that there would be a negative correlation. So the stages that we go through for this hypothesis test are very kind of stage by stage, and very much kind of crank the handle and you can get out the answer relatively easily and painlessly. So the first statement is always this: let rho be the population correlation coefficient. Then we've set up the null hypothesis, which is always the same. Rho is 0. And then we would go for this one-tail test that rho is greater than 0. Okay? Yes, Annie?
Do we need to write like the algebra bit and then the explanation as well?
There is no requirement to write that worded part out for this bit. We will need it, however, for what we're going to be looking at later today. Okay? So if you look back into past paper mark schemes, there's no requirement to write that bit out. Now, for n equals 8 in this case, 5% critical value, you can look that up in the tables, for a one-tail test is 0.6215. And so then you work out the value of R, the sample product moment correlation coefficient for the table, which was 0.696. So because the 0.696 is greater than the 0.6215, we can reject H0. That 0.696 is inside the critical region. So there is evidence to suggest that there is a positive correlation between artistic merit and technical ability. Okay, so that was the setup that we looked at last time. Now, there is a slight problem with the context of this question that we've just looked at. I mean, we could certainly go through all this process, okay? But there was a slight problem with the context, and it's this fact that we've got this technical ability and artistic merit, and they're being awarded for this by this panel of judges, effectively. Okay, and the first statement that we made, let's say A to H are the only gymnasts that are there, the first statement that we made was this: let rho be the population correlation coefficient. Well, if this is my sample, who else is there in the population? Well, there isn't, is there? That's it. So, in the context of this problem, we've actually got a situation where really this isn't really a sample of a parent population, because if that's all that there were in this competition, then potentially that's it. Okay, and that causes a bit of a problem, and that's not just the only problem either, because all of these values are subjective. They're not actual kind of measurements necessarily, and they're all kind of subjective judgments. That causes a problem. So another example might be this. So 2 celebrities judge a talent contest, and each celebrity gives a score out of 20 to each of a random sample of 8 contestants. The scores X and Y given by the celebrities to each contestant are shown below. Okay, so we've got these scores. The correlation between the scores awarded is to be investigated. Okay, so if I pose the question as to why might the product moment correlation coefficient not be suitable, I've kind of hinted at 2 possible reasons for that. this isn't really a sample, okay? This is just it. It's not like there's another 100 celebrities in this talent show, okay, and I'm sampling them. The other problem was that it's subjective. It's all down to kind of like, well, what the two panel judges are actually saying. They're not really measuring it in any way, and that causes a problem. And so, in these cases, we end up using Spearman's rank correlation coefficient, okay? And we use it in a few different cases. One might be that it's not linear, so that would mean that it's not going up in a straight line, but there appears to be some kind of correlation. I'll show you a graph in a moment. It could be that it's not numerical, so it could be that you've awarded grades to it, so like A to E, for example, rather than actual numbers, and whether it's subjective or not. So here is an example of a non-linear graph, okay, of a scatter graph that we've drawn. It's not going up in a straight line, but it does appear that there seems to be some kind of correlation, and we call it rank correlation. Right, so how do we do Spearman's rank correlation coefficient? Right, quick show of hands for people who've seen this before. Oh, you got a good smattering of hands. Okay, brilliant. So you've got an advantage here. Right. Okay, so what we're going to do is we are going to build up a fresh table. So we've got A, B, C, D, E, F, G, H. Okay, right. So we look at the X values that we've got, okay, and we rank them in order of size. So as long as you do this consistently, it doesn't matter if you're going for the smallest to the largest or largest to the smallest, as long as you do the same for the X's and the Y's. So if I go from smallest to largest, that's usually the easiest way to do it. So what have we got? So we've got the 6, so that'd be the smallest, so that would get ranked first, okay? Then what have we got next? We've got the 9 next, so that would be second. Okay, and then we've got, so those are gone, so it would be G next, won't it be? That would be that one, so that's 3. Then with that one gone, it would be the 13, so that would be E, so that would be the 4th one. Then we're going to have the 15, so that would be the next one, so that's 5th. Then we've got, what have we got? The 17, so that would be 6th. Then we've got, have I missed one out?
You skipped the 14.
I've skipped the 14, haven't I? Oh no, right. Which one have I got? So 3 for 11th, 4, 5, oh it's the 15, yeah. So that's the 5, isn't it? 5, then that'll be 6th. See how easy this is to do. It's difficult when you're doing it between boards. We've got the B for 7, and then that would be 8th. Okay, brilliant. So we've got those. So that's the first one. Then we've got to do it for the second group, okay, for the Y's. So this looks like it's going to be a little bit easier because I can spot 6, 7, 8, 9 here. So we're going to have 1. Then we've got the 7, so that's there. So 2, 3, 4, 7, 8, 9. Oh, then we've got 10. Excellent. So that's number 5. And then we've got the 12, and then we've got the 13, and then we've got the 15 at the end. Okay? So what we've done there is we've ranked them in order of size. Okay, so that's what we would do first, okay, to get our set of numbers. Right, so we've got them ranked in order of size now. Okay, right. Can people who've done Spearman's rank remember what comes next? the difference. Yes. So we find the differences. Okay, so we find the difference between each of these place numbers. Okay, so the scoring. So you just do 1 take away 1, 7 take away 7, 2 take away 5, 8 take away 4, 4 take away 3, 6 take away 2, 3 take away 6, 5 take away 8. Okay, so you find the difference in the places. Now what I'm going to do is try to find some way of effectively finding an average. It's kind of like finding an average of all those different places, okay? But if you remember back to look at the standard deviation and how we first calculated it way back, if I add all these up, what's going to happen? I'm going to get minus 3 plus 4 is 1, 2, 6, 3, 0. They should always add up to 0. So to eliminate that problem, square them. Okay, so we're going to square those. So 0, 0, 9, 16, 1, 16, 9, and 9. Okay. Well. Now, Spearman's rank correlation coefficient uses this information and then plugs it into a formula. But don't worry, is given to you, okay? And it looks like this. Now, we're not going to build up the origin of this, okay? It's a little bit beyond our remit. So 6 lots of the sum of the d squareds divided by n lots of n squared minus 1. So can you figure out what the correlation coefficient will be? So substitute into that formula, see if we can calculate it. So we should get 2/7 or 0.286 to 3 sig fig. Okay? So that's how we can calculate Spearman's rank correlation coefficient. And this value, much like it was for Pearson's, will range between -1 and 1. Okay? So, I mean, you can kind of imagine, right, if you got all these differences to be 0, which would mean that the two panel judges had ranked them pretty much in precisely the same way. Well, not necessarily precisely the same way, but if they ranked them in precisely the same way, first to 8th, then all your d's would have been 0, the d squareds would have been 0, so that numerator would be 0, and you'd be left with 1. Okay, so they'd be in perfect ranked order. Okay, so what I'd like you to have a go at is just to make sure that you can do this process. So that will be page 137, question 1. Okay, just a bit of practice on that. Just so we're clear, the formula that we had, this one up here, Spearman's rank, is on page 6, where you found the product moment correlation coefficient material as well. Okay, so page 6, top right hand side of the formula booklet. Okay, right, so one question that we do need to ask is if the ranks were tied. So if you had two positions in the same place. Okay, so maybe there are 2 seconds, for example, right? How do we deal with that? So what we do is that if several items are ranked equally, then we give them the mean of the ranks they would have had if they'd been slightly different. Now what that means in practice is that, let's say I've got this situation here, okay? So I've got first, I've got joint second, then fourth, fifth, joint sixth, ninth, 10th. Okay? So this, the second, the joint second, that covers second and third place. So you're imagining that they are slightly different, okay? So both of those would get 2.5. So the average of the second and third placing. Here we've got 6, 7 and 8. 6th, 7th and 8th. And so all of those would get the average of 6, 7 and 8. So 7. Okay? So that's how we can deal with this issue if we've got a tie in the ranking. Okay? I'm not going to say that's going to come up a lot, but it has the potential to be examined, so you need to be able to know how to deal with that. So you're going to have a go at one of those, just so you're kind of happy with it, and to make sure you get the correct answer. So I believe that's on page 137. Was that the one you were just on? 137, and it's question 2. Okay? So you've done question 1, now have a go at question 2. Okay, so hypothesis testing then. Now the tables that you've used for Pearson's correlation coefficient, which were on page 21, on the left-hand side was the product moment correlation coefficient, the one that we've used before. On the right, a Spearman's rank correlation coefficient. Thank you for the cheer, Ollie. Right. So you'll notice that they are very similar in style, which is great, okay, because if we know how to use the ones on the left, we are definitely going to know how to use the ones on the right, okay? They work in exactly the same way as we've had before, okay? So if we go back to the information that we had before, okay, so this was our table of results. We worked out the Spearman's rank correlation coefficient was 0.286, okay? And so what we're going to do is we're going to carry out a hypothesis test at the 5% significance level to determine whether there is positive association between the scores allocated by the two celebrities. Right. Now obviously there's an elephant in the room there because I'm using the word association rather than correlation, okay? When we're talking about rank coefficients, and we're putting them in order of rank, correlation inherently has a lot of things going for it when we're thinking about, if we think correlation in our heads, we're thinking about positive and negative correlation. We're thinking of it going in a linear, in a straight line, okay, from bottom left to top right or top left to bottom right. However, because this rank correlation, effectively, doesn't have to be necessarily linear, we often talk about it as in terms of association rather than correlation. And so when we detail our hypothesis test here, this is the wording we should use. Okay? So let's see how we do it. Now, Pearson's correlation coefficient started with its hypothesis test by saying, let rho be the population correlation coefficient. Now, there is no rho, okay? So that sentence is gone. You're right, Mallory. Right? That sentence is gone. Bye-bye. The null hypothesis, so we don't even replace it with anything, right? We go straight into the null hypothesis. However, because the null hypothesis for Pearson's correlation coefficient started with rho is 0, and there is no rho, we can't talk about rho, and we say that there is no association between the two scores, say. Okay, between x and y. So now the null hypothesis is written in words. Okay. Now we're going to try and determine whether there is positive association. So H1, the alternative hypothesis, is also in words. And we say there is some positive association. Between the two scores. Okay, so this gives us a one-tailed test, okay, to consider. So what will we do next? Well, for Pearson's coefficient, we would have said for n equals 8, 5% significance level, critical value is, okay, so we looked that up in our tables on the right, okay. So, one-tailed test, 5%, n is 8, we should get 0.6429. Let me write it down here. So much in the same way as we had before, -1, 1, and 0, 0.6429, about there. This is my critical region, and the 0.286 that I've got is down here. So it's not in the critical region. So 0.286 is less than the 0.6429. So we fail to reject the null hypothesis. So we say in a final statement, concluding statement, there is no evidence to suggest, or insufficient, we should probably say, but we can't probably get away with no. There is insufficient evidence to suggest that there is positive association between the two scores. So if you're comparing this to the product moment correlation coefficient, so you've got an idea of these differences, we've got a different way of calculating the coefficient. The hypothesis test does not begin with anything other than the null and alternative hypothesis, which are written in words this time, talking about association rather than correlation. This next stage is precisely the same, but we're using the right-hand tables, so don't get those mixed up. Compare your value against that critical value, and then pretty much the same as we've seen before. Yeah.
In the exam, will it tell you like which one to use, or you have to work out yourself?
Oh, it'll be clear. Yeah, it'll be made clear which you're using. Spearman's rank or Pearson's. Okay. So we've now covered 2 of the 4 hypothesis tests which you could be asked. And you can see there's very little difference between these first 2, but there are subtleties that we need to consider to make sure we get them right. So, you're going to have a look on the same page as you were, question 5, 7 and 10. And then I'm going to give you another exam question, much like we did last time, but this one with Spearman's instead. Okay?
Be an alternative question 1.
Yes. So question 1, you're probably looking at product moment correlation coefficient or Spearman's. There could be a mix between the two, because it could go from Spearman's into product moment, or vice versa, potentially, but it will say. And then the third is linear regression. Okay?